Alright, so I built up another one of these. It's an Intel 14600K build, something we haven't done as much lately. I'll show you how to tweak it a little bit in the Terra. Welcome to Machines & More. There's another Terra build here. Let me show you what's in here, and I'll talk about why you might want to do this build and how to make it work a little bit better than just stock. CPU here is the 14th gen 14600K. It's a solid CPU, but like most K chips in the last few Intel generations, it's quite power hungry. Often with the K chips, since they are unlocked, you might choose to pair with a Z series board like a Z690 or Z790 ITX board, and that gives you CPU overclocking or undervolting functionality. But in this case, since we are cooling limited anyway, we're going to be struggling to even run at stock power levels, so the overclocking features won't really be utilized here. And you can save a lot of resources going with ASUS's B760i, which I have here. And this board is about $220 US at retail, but you can often find it for less nowadays. Just as a reference point, the ASUS Z790i is about $430 US, and MSI's Z790i is about $300 or so. So there is a quite hearty amount of savings by going with a board like this, and I'll show you why this makes sense today. I've got the ID Cooling IS67 heatsink here, and it fits well with this board. In fact, the heat pipe bends being adjacent to the RAM allows the heatsink to overhang the rear I/O cover, and it's just about perfectly clearing, and there's no RAM interference either. You notice I've got this fan swapped here for the Noctua A12x15. There's not a huge performance reason to do it. The stock ID cooling fan actually performs similarly to this one. I think this one maybe just sounds a little bit more pleasing acoustically and synced up with a single case fan in terms of the look, which is an NFA 12x25. So I've got this case in divider position 2, which gives 72 millimeters for the CPU cooler. And you can see there's still a good gap here. This comes in at about 67 millimeters. There's about 6 millimeters here, and that's enough to avoid any turbulent noise induced by the cooler. Here's 2 sticks of Corsair's Vengeance DDR5. This is a 6000 megahertz kit. Power supply I've got here is the Corsair V1100 SFX, which was a little bit handier for me to put into this build. I do also have the 850 watt version, which is what I'd normally go with for a build like this, but just, wasn't handy to grab that one. But both the 850 and 1100 watt VSFX units have a native 12V HPWR port, and comes with this cable, which you can sync up nicely with the graphics card we're using today, which is ASUS's Dual 4070 Super. This card is a little bit thick on the thicker side at 51 millimeters. The official spec for position 2 is 48 millimeters, but it actually clears. And so yeah, this is the old style cable, which from Cooler Master, which works out a little bit better in this case since it plugs straight in versus coming up and then angling in, because then that cable would have to come around and make a little sharp turn here. Here we do have to make a tighter bend this way, but it seems to work out okay. And I'll show you here, the top panel does close down just fine on it, and that doesn't really have a huge issue. And yeah, the graphics card, the side panel does sit pretty close to these fans, but in fact, the large diameter fans here, actually, these particular fans don't seem to have a huge issue with turbulent noise or interference with these side panels, so I was pleasantly surprised about that one. As mentioned, I do have a Noctua NFA 12x25 at the bottom here in exhaust, and I've got a fan grill covering that. Thought about going to position 3, but that would place this right at touching the side panel. I really don't think that works well in terms of the turbulent noise. So for a high-end pure gaming build in the Terra, I usually recommend the 7800X 3D. It's remarkably efficient, and it sips 35 to 40 watts for gaming usually, and it's a very decent performer for multi-threaded stuff. It sits somewhere between the 7600X and the 7700X in my experience for that. And the efficiency, it just jives well with the top-down coolers, the smaller ones that you're limited to in this case. So why would you do something like the 14600K here, right? At stock settings, it's drawing about 105 watts for gaming. So One reason is if you want to do some multi-core stuff with the CPU as well as gaming. So it only has 6 performance cores, but it has 8 E-cores, which still do work, and in most scenarios, it will outperform the Ryzen 7700X while being behind the 7900X. And it'll perform similarly to those two in terms of gaming. Some titles slightly better and some titles slightly worse type of scenario compared to those two CPUs. For that use case, I might argue that the 7900X really would be the best for a case like this. I do have an upcoming build with that to show you, but perhaps one reason would be the platform cost. This is $525 for board and CPU, while the 7700X combo, it's $630 if you use an ASUS B650EI board, which is about $300 US. Now, I still don't enthusiastically recommend this particular setup in the Terra since it draws a ton of power still. With this cooler for a short Cinebench run, it's already throttling and it's finishing at 168 watts at stock. And for 1440p gaming at 105 watts, you know, power cost is one thing, but the higher fan speeds and the noise is another, something you'll notice right away. Plus, you're not getting all you can out of the CPU for multi-core stuff. However, if you do choose to do this build, despite the B designation for the B760i, you can actually undervolt the CPU. So to do that, we'll boot into BIOS. What you can't do right away is set an offset for the global core SVID voltage or your cache voltage. And if you do set an offset for the actual VRM core voltage, which you see an offset option for, you're actually going to drop the single core performance significantly. So what you can do is then go into the tweaker's paradise and under switch microcode, choose the 104 microcode. This will allow for an offset mode to appear under the global core SVID. You can set a negative offset and just start at 0.1 volts and do the same under the cache voltage. Boot into Windows and try a Cinebench run. So usually 0.1 volts should pass for most examples of the CPU. And what you want to do is slowly work your way up, you know, do some Cinebench runs, then maybe dial up the offset to 0.115 volts or 0.125 volts next. What you're actually doing here, you're just trying to do some quick tests to figure out which point will flat out crash, so then you can work backwards to fine tune and test. And once you get a good spot, just run some extended renders, game with it, do what you usually do an extended Y cruncher run or something like that for stability testing. For my build, I set it at 0.125 volts just to show you the testing here. It can actually go a little bit higher, but this is just an example. For Cinebench R23, the 104 microcode with offset yielded similar power draw. We are thermally limited still. It hits 100 degrees almost right away with this cooling setup, and that's perfectly normal. The scores do go up slightly because even though we're not technically overclocking by giving more power, we're still altering the voltage frequency curve. So it is running the CPU faster than stock at the same power. It's better, but is it meaningful? Well, you know, you're still leaving performance on the table. With adequate cooling for the CPU, you can get to high 24K or low 25K scores with this CPU. So, you know, it is what it is. What I'd be more interested in doing with this CPU is reducing the gaming power draw though. Gaming temps with this GPU are quite good. Fans only run at about 44%, and it's quite a good noise profile here. With stock settings on the CPU, we're seeing 105 watts. With the offset dial, 84 watts. It's still a lot, but more reasonable. Temps improved quite a bit, which with the stock curve, it's the difference between 1770 RPM and 1360 RPM, and it's a big change in noise. The single core performance is similar, as evidenced in the Cinebench single core score, so you're not losing performance. If you didn't switch to microcode and you just went in and dialed in an offset for what you could see there, the actual VRM voltage, you'd be dropping performance, single core performance by quite a bit, so really don't do that. So I don't know about other B760i boards since I haven't tried those with the 13600K or the 14600K, but yeah, this board and a 13th gen or 14th gen K chip, you can optimize it a little bit, which makes it work a little bit better. That's not going to make an i7 run in here though. Don't try it. It's too much. I've done it before, so don't do that. But if you are looking to do a similar build in the Terra, just make sure that you actually need the productivity use case, because again, for pure gaming, I would still go Ryzen 7000 and even a 7600 or 7600X build like we did before, last build in this case. That would be comparable in performance just for gaming and have lower power draw. It's going to run quieter and could come in cheaper with the advantage of having more longevity on the AM5 socket. But it's a very interesting build, so if you're interested, definitely check out the links down below, and that'll do it for this one. Please make sure you give a like if you found it helpful, and make sure you're subscribed. Thanks for watching today.